There we go. Perfect. Okay. Sorry guys. I don't know what happened. I had to I was actually busy for a little bit, and then, I had to make sure that well, yeah, I mean, one of the basically what happened was that I was busy with a phone call, and that's why I had to stop the stream. But I am back. So we're gonna go ahead and get started. So let's see. Give me a few seconds. I'm just gonna. So in this live stream, what I want to do is I want to go ahead and kind of look at questions, some random questions from geometry, algebra, trig, pre-calculus, calculus, etc. And if anybody has any questions, you can always let me know. If you do have questions, in case you do have questions, you can always let me know, and I can answer them to the best of my abilities. And let me actually, if you guys could give me 1 second, just really quickly. Give me 1 second, everybody. So, I know that basically, we are, kind of, heading back into the semester or the new school year, as far as, everything is concerned with COVID, and I know there are students that are going back to school in person, and so I just want to make sure that if anybody has any questions, about whether or not you've already gone back to school, or if you are going back to school, this is a live stream that can be open for questions. So basically, I'm gonna go ahead and get started. And what I'm gonna do is I'm gonna get started with algebra, specifically algebra 1, because I know that one is kind of the first one in high school that we look at when it comes to, it goes algebra 1 and then algebra 2, pre-calculus, and then calculus. Or I'm sorry, algebra 1, geometry, algebra 2, and then pre-calculus and calculus. Congratulations for 100 subscribers. Thank you so much. Thank you so much. I really appreciate it. So yeah, I mean, if anybody has any questions, you can let me know. I'm gonna get started on, actually, hold on. I'm gonna get started on, give me a second, on algebra 1, only because, well, yeah, I mean, I know that, I don't know how long the stream is going to be, but I will answer some random questions about algebra 1, and I'm going to be going in rotations, so just a bunch of random questions. And if there's any point that at any point, if anybody has any questions about anything, if you are, wanting me to do a specific topic in a specific math class, let me know, and I will be more than happy to do so. Let's see. Hold on, guys. Okay. So yeah, what I want to do is, so let me just go ahead and do some pretty random problems, and yes, so let's go ahead and get started. And actually, let me change. Hold on. Let me change this to this. Okay. So yes, if at any point you have questions about anything, please don't hesitate to ask me. That's why I'm here to help, and I'll be more than happy to do so. And for some reason, this isn't loading. I'll just do this one. It's fine. So so let's get started. So the first question that I want to do, let's see, is subtraction of two polynomials. So we have x squared plus 15x minus 3, and hopefully this doesn't crash, by the way. I know this one note crashes quite often, and if it doesn't, I'll use the other one. And then we have minus x squared minus 5x minus 3. Okay, so looking at this one, and let me actually take this out of the way. Looking at this one, all you really have to do is go ahead and distribute your negative in. So anytime, for example, if I say 2x, and then if I say, let's say, like 2x minus 3 minus x, I'm going to distribute it, and I'm going to do minus x, or if I say minus x plus 4, I'm going to distribute it. Anytime you have a negative, if I have negative the quantity x plus 2, that's really negative x minus 2, right? So that's how you do that. Yeah, give me 1 second. I want to make sure that my audio is good, because I really don't know, and I just want to make sure that you guys can hear me properly. Give me 1 second, guys. Hold on. Okay, so yeah. Now, so for this problem, what you're gonna do is you're gonna go ahead and distribute your negative in, right? So really this becomes x squared plus 15x minus 3 minus x squared plus 5x plus 3. And now all you really have to do is combine like terms. Let me get a highlighter if I can. Hold on. Okay, So you have x squared, negative x squared. You also have 15x and 5x, and then you also have negative 3 and 3, right? So then basically you want to bring them together. X squared minus x squared plus 15x plus 5x minus 3 plus 3. And this becomes, so these two cancel out, and you're left with 15x plus 5x, which is 20x. Okay? And that's how you do that first one. Okay, so now we're going to do systems of equations by substitution. Yeah, I'll do this one by substitution, just because. So, systems of equations. And like I said, if at any point anybody has any questions, please let me know right away. But I am doing really random problems, and this is from an app where you can do practice problems for algebra, right? Let me hold on. Okay. I think it was it 7? No. Ugh. I don't remember which one it was. Oh my goodness. Okay, I think I got it. This one. Number 3. Okay. So, so this one, we want to solve for x, so we have 2x, so we have the following. 2x plus y equals 13, or sorry, 12, excuse me, and x minus 3y equals 13, right? And what you want to do is you want to solve for x. Now, there's two ways you can do this. You can either do this by substitution or elimination, okay? Now, what I'm going to do is I'm going to go ahead and color code. So let's say that this is y, right? 2x plus y is equal to 12. And I'm going to do this for my y term. So x minus 3y equals 13. Now, in one of my equations, what I'm going to do is I'm going to go ahead and solve for y. So 2x plus y is equal to 12. And I'm going to go ahead and subtract 2x on both sides. And so that's going to give me y is equal to 12 minus 2x, right? So then you put that in for y, right? So this is my equation for y equals. Now, I'm going to put that in for my second equation. So this one, I'm going to put this in over here. So now I'm going to have x minus 3 times the quantity, 12 minus 2x equals 13, right? And then we're just going to go ahead and distribute. So we have x minus 3, and then it's going to distribute. So x minus 36 plus 6x equals 13, right? So then we can combine like terms. So we have x here, and then we also have a 6x here. x plus 6x is 7x, right? And then minus 36 equals 13. And then we add 36 on both sides. We get 7x equals 49, and we divide by 7 on both sides, and we get that x equals 7. Okay. Let me know if I'm going too fast, because I know that sometimes I go a little bit fast. Also, let me put live chat, just in case anybody wants to, so the answer is x equals 7, right? Okay, so the next one says we want to evaluate the following. So this is number 3. So we have 2x squared minus 4x plus 7 times x squared plus 3x minus 8. So what you're going to do is you're going to go ahead and do distributive property. Now, you can either do this using FOIL method or you can do it using box method. Also for this last one, I'm so sorry guys, hold on. For this last one, I also want to do it using elimination. So if we want to do it using elimination, the way that we would do it is the following. So if I actually grab, so if I do it again, 2x plus y equals 12, and 3x, or x minus 3y equals 13, by elimination, I can eliminate my my y term. So what I can do is I can make it so that the y's cancel out. So I can multiply. So let me let this actually, hold on. So this is equation 1. Multiply by 3 in equation 1. So basically you have 3 times the quantity 2x plus y equals 12. And then, I mean, obviously, if you're multiplying by one side, you're going to do the other side as well. So because we're multiplying the equation 1 by 3, on the left side you're multiplying by 3, so that means on the right side you're going to multiply by 3 as well. That's like if I say, like, x plus 3 equals 6, so that means that 3 times x plus 3 is going to equal 3 times 6. That's because of the fact that if a equals b, then AD equals BD. Okay, that's a property. It's a multiplication property. So what I'm gonna do is so by elimination, I do this, right? And what happens is that I distribute. I get 6x plus 3y equals 36, right? And so what happens is that let's see, hold on. Six x plus 3y equals 36. Right, and then so this equation becomes this. So then now I have the following system. 6x plus 3y equals 36, and I have x minus 3y equals 13. Now I'm going to go ahead and add them both. So when I add them, I have 6x plus x, that's 7x, and then this cancels out, and then this becomes 49. So really, I divide by 7 on both sides, and I get that x equals 7, which is exactly what I got when I did it by substitution. Okay. So you see, I did this part by substitution, and this was by elimination. And you see how I got both, I got the exact same thing for both, right? So let's look at the next one. Okay, so this one is a little bit tricky. With this one, I mean, it's not systems of equations, but it is multiplying polynomials. So, with this one, it's a little bit tricky because you have to be careful with how you do your FOIL method. Now, with these kind of polynomials, what I really recommend is that you go ahead and you actually, what is it called? You actually, I literally forgot. So you have to do, it's really recommended, and I really highly recommend that you do a box. So I can do it with FOIL method, but it's just a little confusing to explain it with FOIL method, but I can do it with FOIL method. So what happens is that so we have this, and then we also have this, and then we also have this, right? And you're basically doing this for every single term. You're distributing every single term to every term. So like this. Okay. Now what happens is that you have, so this becomes 2x squared times x squared plus 2x squared times 3x plus 2x squared times negative 8. And then it's going to be plus negative 4x times x squared plus negative 4x times 3x plus negative 4x times negative 8, and then plus 7 times x squared, and then plus 7 times 3x, and then plus 7 times negative 8. Hold on. So, yeah, this is the entire thing that you're doing. And this is what we call FOIL method. Okay. So basically, yes, this is FOIL method, and this is how you do it. Now, this, I mean, honestly, doing it this way is a little bit tricky, especially when you have two trinomials that are being multiplied. Now, what is a trinomial? A trinomial is an equation with 3 terms. So that's like x squared plus 2x plus 1, 2x plus x cubed plus x squared. So you have 1, 2, 3, 1, 2, 3. It always has 3 terms, right? Now, we can simplify this. So this becomes 2x to the 4th. This becomes, so and then we have plus, and then this becomes 6x cubed. And then we have minus, this becomes, or actually plus, and then this becomes negative 18 or I'm sorry, negative, oops, it becomes negative 16x squared. So, and then this becomes negative 4x to the 5th, or 4x cubed, excuse me. So, really what is happening is that you're multiplying every part. So, it is a lot, in my opinion, this is a lot simpler to explain with a box. Because, I mean, I would explain it by different colors, but it will take really long. And then we have plus 32x, or I'm sorry, plus, it would be plus negative 12x squared, excuse me, and then plus 32x, and then plus 7x squared, plus 21x, minus 56. So, as you can see, this method is a little bit tedious, okay? So you have 2x to the 4th plus 6x cubed minus 16x squared minus 4x cubed, and then minus 12x squared, and then plus 32x, and then plus 7x squared, plus 21x, minus 56. And then, sorry guys, give me 1 second. So then another thing that you have is so once you do this, you go ahead and just combine like terms. So you have negative 16x squared, negative 12x squared, 7x squared, and then you also have 6x cubed, negative 4x cubed, and then you also have 32x, 21x, and then you also have negative 56, and the 2x to the 4th is just another one on its own again. So, I mean, 2x to the 4th is another term that is on its own. So you have 2x to the 4th, and then 6x cubed minus 4x cubed is 2x cubed, so it's going to be plus 2x cubed, because this is what it becomes. And then negative 16x squared minus 12x squared plus 7x squared, that is negative 28x squared plus 7x squared, that is negative 21x squared. So this becomes this part here. It looks a little confusing, but, you know. And then you have, plus 32x plus 21x, so plus 53x, and then minus 56. Give me 1 second, everybody. So then, what you're going to do is you're going to go ahead and so basically this would be your answer, right? Now, this is using FOIL method. Box method is a little easier. I'm going to do it using box method now. 2x squared minus 4x plus 7. So what we're going to do with box method is you have to draw like a box like this. And you have to make it so that it goes into 3 by 3. So with box method, you have to make sure that all of your equations fit. So you have 2x squared minus 4x plus 7. Let me just do it this way. Hold on. Okay. So I'm going to put, it doesn't matter where you put which one, as long as you multiply it correctly. So you can do it this way. And then times x squared plus 3x minus 8. Right? And the way that you would do it is, so you would say 2x squared times x squared. So you have 2x squared times x squared. And, you know, I mean, of course you can simplify it from there. 2x squared times x squared, that's basically 2x to the 4th, right? So we can just write 2x to the 4th. And then we have a 2x squared and a 3x. 2x squared times 3x, that's really just 2 times 3, which is 6, times x squared times x, which is x cubed. So it's going to be 6x cubed. And you can put a plus if you want, so that way you know that you're, you know, at the end you're going to add them all together. On the very first one here, on the corner, you don't have to put a plus because that's what you're starting with, right? And then you have negative 8 times 2x squared. So again, negative 8 times 2x squared, that's going to be negative 16x squared. And then you have negative 4x times x squared, that's going to be negative 4x cubed. So negative 4x times x squared. And then you have, let me go ahead and write these down. So negative 4x times 3x, that's really just negative 12x squared. And then negative 8 times negative 4x is 32x. And then you have 7x squared, so 7 times x squared. So you always want to, I mean, one of the things that I would like to do is like put a little times symbol here so that you know that you're multiplying. And then you have 7 times 3x, that's going to be 21x. And then you have 7 times negative 8, which is negative 56, right? So then you just get them all together. So 2x to the 4th plus 6x cubed minus 16x squared plus 4x cubed minus 12x squared plus 32x plus 7x squared plus 21x minus 56. And once you do that, you just go ahead and combine like terms. So this you have, I mean, you can highlight them if you want. You have 6x cubed, 4x cubed, and then you also have negative 16x squared, negative 12x squared, and then you also have, oh, you also have 7x squared over here. And then you also have 32x, 21x, and then the negative 56 and the 2x to the fourth can be of different color. That is if you want, but those two are the only ones left over, so you don't really have to do anything with those. Hold on. So, okay, so from here, what you're gonna do is you're gonna go ahead and do 2x to the fourth, and then you have plus 10x cubed. Because, well, you can rewrite them together. So 2x to the fourth plus 6x cubed plus 4x cubed minus 16x squared minus 12x squared plus 7x squared, and then plus 32x plus 21x minus 56. And like I said, you can, I mean, you can re-highlight them or you can relabel them if you want. Just so that you know that, you know, it's like this, and then you have, we have our x squared terms like this, and then you have our x terms, which are these two, so, and then we just have our constant, which is our negative 56, right? So then this ends up being 2x to the fourth, and then 6x cubed plus 4x cubed, that's just 10x cubed. And then minus, and then 16x, so negative 16x squared minus 12x squared plus 7x squared. So if we go ahead and do that separately, this can be, so we're really just subtracting two negatives, or adding two negatives, excuse me. So really it's just going to be negative 28x squared, and then we have a plus 7x squared here, so this ends up being negative 21x squared. So this ends up being minus 21x squared, right? And then from there, we go ahead and say, so 32x plus 21x, that's going to be 53x. So that is, so let me go ahead and just label so far what I have. So basically how I got everything. So this is how I got 10x cubed. So like this, right? And then negative 21x squared, I got it like this, so. And then we have 53x, I got it like this, right? And then negative 56 is just the one left over, which was this blue one here, this blue one right here, right? So basically that is what is left over. And now so now let's see, like this, right? And then as you can see, that we don't have any more to combine, right? So our answer becomes 2x to the 4th plus 10x cubed minus 21x squared plus 53x minus 56. And this is our final answer. Okay. That is for that question, right? Let me go ahead and go on to, maybe I can probably do geometry if I can. I'll do my best because geometry is a little bit tricky. It can be tricky. Hold on. Give me 1 second, everybody. Okay, so we have this problem. This is for geometry. And it says if the radius is 6, and the central angle is pi over 24. So let me go ahead and just hold on. So give me a second, guys. Hold on. Give me 1 second, everybody. I'm just trying to see how to put the pi symbol. Okay, hold on. Central angle is pi over 24. Find the arc length. Okay, hold on. So if the radius is 6 and the central angle is pi over 24, find the arc length. I think I know how to do this, but it's been a while. So, we know that, so if we have a circle, hold on, let me draw a circle. Right? That's a circle. And, we have it's saying that the radius is 6, so the radius is 6. And it's saying that the central angle is pi over 24, right? So if I do kind of like something like this, and it's saying that this angle is pi over 24, right? And what happens, so basically, we want to know what the arc length is. Now, the formula for arc length is the following. S equals R theta. Now, here, theta is this part. That's theta, pi over 24. The 6 here is the radius. So 6 is actually my radius. So basically, to find arc length, all you have to do is do this. S equals 6, and then times, and it's going to be pi over 24. So basically, S is going to be equal to 6 pi over 24, and you can reduce that, and you get pi over 4. So S equals pi over 4. Okay. Hold on. Okay, so it says, so let me see, hold on. Okay, so let's go ahead and look at this one. I don't know why, hold on. Sorry, let me write that down again, guys. Hold on. Give me 1 second. I don't know why it doesn't. I'm gonna just write the problem down, or write the question down, so. Give me 1 second while I do this. So, forgive me, everybody. Just 1 second. So, hold on, guys. Okay, so this is the question. It says the coordinates of a triangle are -4, 2, -3, 6, and -2, 2. What are the coordinates of this triangle after it is reflected across the y-axis? Now, we can draw this out, or we can sketch it, whichever one you want. If they give you a sketch of it, usually, so let me just do a a graph really quick. Hold on. Okay, so let's just do a graph really quick. So 1, 2, 3, 4, 5, 6, 7, and then -1, -2, -3, -4, -5, -6, -7, and then here is -1, -2, -3, -4, -5, -6, -7, and then here is 1, 2, 3, 4, 5, 6, 7. Okay, so this is the graph, right? I'm gonna go ahead and label or plot the points. So the first one we have is this one, -4, 2, right? So I'm just gonna go ahead and do this. So this is -4, 2 right here. Right? And then we also have -3, 6. So -3, 6 is up here. So, oops, up here. -3, 6, right? And then -2, 2 is over here, so now what it is saying is what would be the results of these two or of these 3 points if it is reflected across the y-axis. I can try to do a triangle. Hold on. Give me 1 second. I can try my best to do a triangle like this. Okay, I think that's good. And it wants to know, now the one thing I would do is I would try to like label in any kind of way the line of reflection, because doing so, it helps a lot. So the way that you would reflect this across the y-axis, so think of it as a mirror. So you're gonna just go ahead and do 1, 2. So in this specific point, which is -4, 2. So if I kind of just label it like this, right? I'm gonna go ahead and say 1, 2, 3, 4, and then I'm gonna count another 4 units. 1, 2, 3, 4. So it's gonna be 4, 2. That is for this point, right? And then, hold on. And then this point, which is -2, 2, I can do the same thing for that one. So I can say 1, 2. So you're gonna think about like how many units does it take for me to get from this point to the y-axis, and then you're gonna do it however many points you count. You're just gonna count another 2 for that to make the reflection. So it takes 2 units, right? So 1, 2, and then you're gonna count another 2 units. 1, 2. It's gonna be right here. And then for the third point, which is this one here, -3, 6. So you're going to do 1, 2, 3, and then you're going to count another 3 units. 1, 2, 3. So this would be your new shape after it is reflected across the y-axis. And it doesn't have to be perfect, as long as it's pretty accurate. But yes, this would be this would be the reflected shape. Okay. So the points would be 2. So this point is 2, 2, and then this one is 4, 2, and then this one is 3, 6. So really the points after reflection would be would be 2, 2, 4, 2, and 3, 6. Okay, and that is how you would do that problem. Let's see another question. Let's see. Hold on, guys. Hold on. Give me 1 second, everybody. I'm trying to see what other problems there could be. Um, give me 1 second. I don't know what other ones there could be for this. Oh, give me 1 second. I don't know what other problems there could be. If you have any other problems that you want me to look at as far as geometry goes, let me know. I'm gonna move on to Algebra 2. Which Algebra 2, Algebra 2 is a little more, how do I say it? Like, it's a little more tedious, if I do say so myself. So, let's see. Hold on. We're gonna do some, actually, let's do some exponential equations and logarithmic equations. So, obviously, when they first teach you about exponential and logarithmic equations, the first thing that you look at is, you know, something, it's a very simple kind. It really is not that hard. You just have to make sure that you understand how to make it in terms of a power. So we know, for example, like 2 to the x equals 8. We know that 8 can be known as 2 times 2 times 2, or 2 cubed. So basically, we can change this so that, so for example, if I have 2 to the x equals 8, I can rewrite this as 2 to the x equals 2 cubed. And so since the bases are the same, x will then be equal to 3. Okay. You could also do it mentally, but it is really important that we do this, like, you can do this in your head. If you think about it logically, like, you can say, well, 2 cubed is 8, so x equals 3. Well, yeah, but, you know, it's very important that you understand the process, the algebraic process behind this, because for some other problems, it's going to be a little bit harder to do this. For example, let's see, hold on. 5 to the 2x minus 3 equals 25, right? And this one is a little trickier, right? Because, obviously, it's a little more confusing. Now again, I'm going to do it the same way that I did the previous problem. The 25 can be rewritten as 5 squared. So, really, you can go ahead and say 5 to the 2x minus 3 is equal to, and then you can rewrite the 25 as 5 squared. So that way you have 5 to the 2x minus 3. So you basically have something like this. And, let's see, hold on. So if you can rewrite it this way, hold on, you can do it this way. So if you have like this, you can rewrite it as 5 squared, right? And then you're gonna have, so basically this turns into, so you have 5 to the 2x minus 3 equals 5 squared. And you see how they have both the same base now. So you can say, okay, 2x minus 3 equals 2. So then you add 3 to both sides, you get 2x equals 5. And you divide by 2 on both sides, you get x equals 5 halves. And that is how you would do it. Now there are some of them that are really tricky. So, for example, let's see, hold on. I'm trying to see which kind are really tricky, because I kind of don't remember. Hold on. Exponential equations. Okay, so we can do this kind. So 3 to the x plus 2 equals 9 to the 2x minus 3. Now, this one is a little bit tricky. You have to make it so that the 3, or basically so that the 9 is in terms of 3. So if I change this to this, like this, right? I'm gonna do it, so the left side stays the same, 3 to the x plus 2, and the right side I'm gonna make 9 into 3 squared. And then I'm gonna put to the 2x minus 3, because the 2x minus 3 stays there, right? It still stays there, nothing happens to it. So then you have 3 to the x plus 2 equals, and what you're gonna do is you're gonna say 3 to the 2 times 2x minus 3 power. So now, what happens, and give me 1 second, guys, meanwhile I connect my... Give me 1 second. Okay. So, okay, so you have 3 to the x plus 2 equals 3 squared to the 2x minus 3. Now, what happens is that this, so now you have the same base, however, you're just gonna grab this part and you're gonna make it equal to this part. As long as they have the same base, and the base is basically what the base is like, it is the number in the very front of your exponential equation. So the 3 is equal, so there's a 3 here, and there's a 3 here. So that means that the bases are the same. So as long as the bases are the same, then you can go ahead and make the powers equal. So x plus 2 equals 2 times 2x minus 3. So then this gives you x plus 2 equals, and you're going to do distributive property, 4x minus 6. So then you're going to subtract x on both sides, and you have 2 equals 3x minus 6. and you're going to go ahead and add a 6 to both sides. So, and you get 8 equals 3x. So then you divide by 3 on both sides, and you get x equals 8/3. So those are what exponential equations are. Now, sometimes an exponential equation can be a logarithmic equation in disguise. So, obviously, when we have, so there are two types of, there's another type of exponential equation where you have to use logarithms, right? There can be this kind where you have e to the x plus 2 equal to 4. Now, obviously, we don't know how to do this by using, power of a power property. And what I mean by power of a power property is what I was saying over here. Like 3 squared to the 2x minus 3. That's literally like saying a to the nth, or really that's really like saying a to the x to the y power, which is really just a to the x y power. Give me 1 second, guys, hold on. Okay, sorry everybody, I'm back. Sorry, I was getting some tea. I got real thirsty. Okay, let me, maybe I can do, what is it called? Give me 1 second. I'm gonna try to do and if you guys hear a dog barking in the back, I am so sorry. It's because I think they're fixing the satellite and I don't know what they're doing. Hopefully the internet doesn't go out. I'm just saying. Give me 1 second. And also, if you guys hear my Alexa go off in about 10 minutes, because I have to take my medication, because I take it every day at around 2, so, yeah. Give me 1 second. I'm gonna try to add... Excuse me. Okay, for some reason... Hold on. Give me a few minutes, guys. I'm so sorry. Properties. I just want to make sure that I put a camera in front so that you guys can see me. Okay. Sorry about that. Okay, give me 1 sec. I'm gonna go use the bathroom. I will be right back. Just give me 1 second. Sorry. Let's see. Okay. So, let me go ahead and, go back. Okay. Hopefully it's good now. So that way you guys can see what I'm doing, and if you guys see that, like, I'm like really close to the screen, I do apologize. Just because I literally, when I do my problems or whatever, I grab my laptop and I put it literally right in front of me, because of course I have to what is it called? Make sure I write the problems correctly, and just, you know. But anyways, let's continue. So this one is a little different. This one, I would like to say is it's a little bit different. So the thing is about this one that we cannot usually take, like we can't use the power rule of exponents to, or the power property of exponents to do this, right? So basically what we have to do is we have to take the natural log, or you can take, I mean, when it comes to this, yes, take the natural log, because anytime you have an exponential, like with the power e, or with a base of e, so this right here, you always take natural log, right, or ln. And like I said, guys, if you guys do hear in about 6 minutes at 2, if you guys hear my Alexa going off, again, I do apologize in advance. So, basically, what you're going to do is you're going to take the natural log. So take the natural log of this. So basically, number 1 take natural log of both sides. So then that's going to be natural log of e to the x plus 2 equals the natural log of 4. And we have x plus 2, so then here's another thing. The x plus 2, so let me just label it this way, hold on. I'm going to label it blue, and there's a reason for that. What happens when you take the natural log of something? So basically the natural log of x to the n is really just n times the natural log of x. So really, this is what it is, and you go ahead and you do it that way, right? So you're gonna do the same thing here on the left side. You're gonna have, so it's really gonna be x plus 2. You're gonna move this to the very front, and you're gonna put it all in parentheses, and then times the natural log of e. Right? And what is the natural log of e? Well, one of the things that we must know by memory is that the natural log of e is always 1, because e to the 0 is 1. Hold on. Well, actually, I'm kidding. No, it's not. It's not because of that. This is just a common property, okay? It's just a common property. Natural log and e always cancel out. So natural log, when you take the natural log of e to the something, you always use power property and then just use it's just going to end up with the power. So, yeah. That's just how it works. Natural log of e equals 1. That is always a property. That's always true. So basically, you're going to have x plus 2 times 1 equals the natural log of 4. So really, you have x plus 2 equals the natural log of 4. And to solve x, you're going to just subtract 2 on both sides. And like I said, guys, if you guys hear if you guys hear something outside, I do apologize. But because they're cutting the grass and yeah. So then you're gonna have x is equal to natural log of 4 and then minus 2. Okay, guys, give me like about 2 minutes or so, because my Alexa's about to go off. And, yeah, give me like 2 minutes. Okay, guys, sorry about that. I literally had to, pause it for a few minutes because, and like I said, if you hear a dog barking, I do apologize. So, our answer here is x equals natural log of 4 minus 2. And you can approximate, depending on what they tell you to approximate to. If they tell you to approximate to the nearest hundredth, so hold on. So to the nearest hundredth, hold on. Natural log of 4 minus 2. To the nearest hundredth, it is gonna be about negative 14,000, excuse me. Okay. And then, if you want to do it to the nearest, to the nearest hundredth is going to be, or to the nearest thousandth, sorry, hold on. It's going to be negative 614,000, or you can say negative 0.614 if you like saying it like that.
Just to find table sheet.
Sorry about that, guys. They're gonna come in a few minutes. I do apologize. It's, because they're cutting the grass, so my sister just told me to, make sure I pay them. Because usually after everything is finished, we pay them and we give them like a snack or whatever, and as gratitude. And I do apologize. Things seem a little bit like not so smooth in this stream. But like I said, I am doing my best to help everybody. Let me hold on. Let me actually just put a let me see. I'm not sure why it's not showing up. Hold on. Give me a second, guys. I am so sorry. I don't know why. There we go. Perfect. Then again, not sure why it's not showing up. Okay, for some reason it doesn't want to show up. Give me a second. Yeah, for some reason. I don't know, the thing about this is that I made it so that, because I don't know why I have so many video capture devices on my OBS, and I have to make sure I get a lot of them out. Give me a second, guys. I'm gonna I do apologize in advance. Okay, oh my goodness. There we go. I think that's better. If the bed looks a mess, I do apologize. There's not much stuff in it, but yeah. Okay, so I will be right back. Everybody, I do apologize. I know, like, this stream has had a few interruptions because of what they're doing outside. I don't know if you guys cannot hear me, let me know, because I mean, obviously I want to make sure that you guys can still hear me, but give me 1 second. Meanwhile, I sort it out for a few minutes, actually, because I'm sure they're going to be knocking and ringing in the doorbell. And so, yeah, like I said, I do apologize if anybody's watching or if anybody wants to watch this, because, yeah. So I will be right back. Okay, guys, I'm back. I'm so sorry. Oh, there's been a few interruptions, but I am back. So, so with natural logs, it works a little bit differently. Let's see, hold on. So, in this problem, you know, to round, basically, if you want to round to the nearest thousandth, you always look at the number that is after. So, to 3 decimal places is usually to the nearest thousandth. Now, if you wanted to round to the nearest hundredth, hold on. So basically, and actually, let me, hold on. And I know, guys, I keep apologizing, and it is because it's just crazy. Hold on, give me 1 second. I just need to make sure that there we go. So, sorry guys, hold on. Okay, sorry about that. So, to the nearest thousandth, it would be negative 0.614. Now, if you want to do it to the nearest hundredth, so, basically, so to the nearest hundredth, you have negative, hold on, negative, give me 1 second. So, if you want to do to the nearest hundredth, you're going to look at the number after. So this really becomes, I mean, if you think about it, yes, it becomes kind of, you know, it's a 3. You don't look at the numbers after. You just look at the number 3. And to round to the nearest hundredth, you're really just going to say, okay, well, because 3 is less than 5, right? You're going to just go ahead and say that this rounds to negative 0.61. This is to the nearest hundredth, right? Now to the nearest tenth, again, you have negative 0.613, right? And you're going to look at the number that is right next to negative 0.6, because so the nearest tenth is really just 1 decimal place, and you're just going to look at the number after. So because it's 1, it really is just negative 0.6. That is to the nearest tenth. I mean, I'm not going to go so in depth with how to round, but that is probably the only example I'm going to go over. Now, when it comes to, now the last 2 things that I want to do in this tutorial is how to do exponential and logarithmic equations. So there are logarithmic, or I'm sorry, exponential equations where you have to take the natural logarithm. So let's say we have, so give me a second. I'm trying to figure out like what is a good one. So let's say we have 2 to the x minus 3 equals 3. And you're wondering, like, okay, how much, like, you can't really use power of a power property. So what can we do? What we can do is we can take the natural log of both sides. So we have the natural log of 2 to the x minus 3 is going to be equal to the natural log of 3. And then, so basically like this, hold on. Like this, right? And so then you use the power rule, so this right here is your power. So if I kind of relabel it, you have x minus 3, and then you're going to put it all in brackets, and then times bracket the natural log of 2, because when you move the x minus 3 to the front, it just you're just multiplying it back to the natural log of 2, right? Times the natural log of 2. And then this is going to equal to the natural log of 3. Now you're going to go ahead and use distributive property. So you basically have x minus 3, so you have natural log of 2 times x minus 3. You're going to do distributive property. Now this is where you have to be careful, because when you multiply x to natural log of 2, so basically if I say the natural log of u times v, this is really just, or really, hold on. If I say the natural log of u times v, this really becomes v natural log of u. Now the common misconception is that we tend to say that it is this. Hold on. Which this is not true. So you should never do this. Because if I say, for example, natural log of 3 times 5, is this really equal to natural log of 3 times 5? So let's go ahead and go on Desmos really quick, just so you guys can see what I'm talking about. So let me, hold on. Let me change it to the other display so that you guys can see what I'm talking about. Sorry guys, hold on. I don't know why it's not showing the display. Okay. So basically, let me go onto here, Desmos, and I can show you guys what I'm talking about. So basically, Sorry guys, hold on. So basically, let me just show you guys what I mean on Desmos, what I'm talking about when I say natural log of 3 times 5 is really not 5 natural log of 3. Or, like, I will show you right now what I mean. So, hold on, guys. 1 second. Where did I put my... Oh, here it is. So let me just show you. And sorry guys, I know it has been like when I live stream, usually it gives me the freedom of like not everything is like, because I cannot pause it. Usually I can't, you know, like you would see me trying to do everything that I'm doing here, because I can't pause it. So so let me just show you guys what I mean. So let me actually put it's a little bit smaller. So when I or actually let me move myself over here and just do this. Okay. I'm not gonna be graphing, but I will be doing like what is it called? I will be putting in some things so that you guys can understand what I mean. So when I say the natural log of 3, so okay, give me a second. So when I do the natural log of 3 times 5, you see that's approximately 2.708050211. Now what about if I do the natural log of 3 times 5? You see how they're both different? So really, you can tell that basically it's this certain property. So give me 1 second. I'm gonna do another, oops. I'm gonna do another window, and I will show you guys what I mean. Like I will show you guys a property that goes with this. So, hold on. Actually, I'm gonna move this over here. And let me move this over here. Okay. So, the one that I was, the basic, or the property that I was talking about is the following. So, but Sorry guys, hold on. Okay, so this is the property that I was talking about. Let me put control. Let me put insert equation. So log and I forgot how to do base. How do you do base? Sorry guys, give me 1 second. So hold on. So log base, and let me put b of log base b of x. Let me put y. Actually, that color looks a little bit. I hope y'all can see that properly. I don't know. Let me just hold on. Okay, log base b of xy equals and actually let me put some okay, hold on. So log base b of xy equals, and it's gonna be, we obviously know that it goes like this, log base, so log base b of x, and then plus, and then log base b of y, which I know this is like a really crappy way to write it, but and then what my point is with this is that it is not the following. So me just rewrite, let me just copy and paste this again. Hold on. Oh, I literally forgot. Hold on, give me a second. Hold on. So what my point is, my point was this. Hold on. So it was to say that now let me just put log of xy. So let me just hold on. Let me just put this part. So not the following. So this. So basically, log base b of give me a second, guys. So following is not true. About logarithms. So that is log. So again, let me just copy this part. Log base b of xy is equal to, so what I'm going to put is not equal to. So this is what I want to put. This is not equal to it's not equal to the following. Hold on. So log base b of x sorry guys, I'm trying to see how I can say this properly. Hold on. Because I know what I want to say. I know what I'm trying to say, but I just... Log base b of xy log base b of x times, I mean, there's a few things that it is not equal to. So this is one of the following. You cannot say this, okay? This is not true. That's why there's a not equal sign here. This is not equal to this, right? Also, hold on. So basically, my point is that if you have log, so let me just insert one of the common logarithm of 10, right? If I say log of 3 times 5, basically what I'm trying to say is this. Okay, and then I'll move on, because I really don't want to over explain this either. Point is that so the point is that the log of 3 times 5 is equal to log of 3 plus log of 5. That is if it has a common logarithm of 10, which is why we don't put a base under, right? Because it's a common logarithm of 10. And another thing is that you cannot say the following: log of 3 times 5 oh my goodness. Sorry, guys. So this, let me see how I can write this one. This is not equal to log of 3. That's another one that I really want to make sure that we understand. And also, hold on, I'm trying to see. Log base b of xy log of 3 times log of 5, and then on. And also log of 3 times 5 is not equal to log of 3 times 5. I'm literally listing a bunch of properties that can and cannot be true for logarithms. That is exactly what I am doing here. That is so we can understand the rules about this, because I know that these can be very difficult and we can confuse it really easily. The the main idea here is you just want to make sure you understand this, okay? This is the one you want to make sure you understand. The one that, so the other one that I was talking about earlier, that was, I think it was the power property, which I think, I'm not sure if I went over it, but it is the following. So let me go ahead and put it in. Log, so hold on. Log base b, so log base b of x raised to the hold on. Raised to the, let me put a different color. Raised to the just do it like this. Raised to the p power equals it's going to equal the following. E, that one. It's going to equal p log base b. So log I can put times log base b. Times log base b, which should be this one. And if I'm taking forever to do this, guys, I'm so sorry. It's because this is computer. I mean, I would do it with my OneNote, but I want to make sure it looks really, really clear. Because I know sometimes my handwriting can be pretty crappy, so that's why I do it this way. Of x. Okay, so that's basically how you do it. Or you can also get rid of this and just say it like this, p log base b of x. That's how you would say it, right? This is the power property, okay? So the thing about logarithms is that, yes, it can be very confusing if you don't do it the way that you should be doing it. And that is why it's very important that you really study the properties, because if you don't, then it's just going to be a lot harder. Give me 1 second, guys, while I put Meanwhile, I put it back to where it was before. So, so that's how logarithms work. I mean, you can't. My point in all of it was that, in that whole part that I went like over 10 minutes, I went 10 minutes over, was that you cannot say that. Basically, you have to be careful with how you do this. Okay. That's why with this, we said, oh, this is ln of 2 times x minus ln of 3. So here we can say that this is x ln of 2 minus 3 ln of 2 equals ln of 3. So then you have plus 3 ln of 2 plus 3 ln of 2, and then you have x natural log of 2. This cancels out, is equal to natural log of 3 plus 3 natural log of 2. So then you divide by the natural log of 2 on both sides, and you get x equals natural log of 3 plus 3 natural log of 2 over the natural log of 2. And you can approximate it, depending on what you can approximate it to. So yeah, that's kind of how you would do that. Now, if they give you a certain problem like this, and you're kind of like, well, how do I do that, right? The way that you do it is you have to make this part a power of e. So you have to make it so that they both have a power of e on both sides. Yes. So basically what you do is you do the following. E raised to the natural log of x minus 4 is equal to e cubed. So then you're going to go ahead and and put this natural log of x minus 4 in the very front. And then you're going to put times e, and then is equal to the natural log. Or actually, hold on. E cubed, e to the natural log of x minus 4. Huh. Give me 1 second, guys. Okay, hold on. Let me see. It's been a while since I've done one like this. Natural log of x minus 4 equals 3. Okay, so okay. This one's a little bit weird. Hold on. I go to give me a second, guys. I'm just gonna try to see how this one is done, because this one's a little bit weird. Natural log of x minus 4. So sorry, guys, give me a second. So natural log of x minus 4 equals 3. E to the natural log of x minus 4. So you do natural log of x minus 4 times e, so then it would be e natural log of x minus 4. Or really, it would be natural log of e oh, it's just weird. Hold on. Let me look up something, guys. Hold on. Look up something. It's just weird because I feel like this one, oh, I don't know why, I feel like this one's a little bit tricky. Because it does have an answer, it's just that, hold on, let me see, maybe I can look at it in, maybe I can look at it on an app. Because I know I've seen one of these before, but I don't remember how this is done. Give me a second, guys. So, solving and graphing logarithms. Okay, hold on. Simplifying logarithms. Natural log. Because I know there's a way to do this one, I just don't remember. I feel like these kind are really, they're kind of rare. Because usually they wouldn't give you, I mean, if they do, because usually they would give you ones where, yes, you have to use natural logarithms, but these are a little bit tricky. And I don't remember how to do, it's been a while. It has been a while since I've done these. So give me 1 second. Natural log of if I do natural log of x minus 4 equals -1, let me see, what about that one? Natural log of x minus 4 equals -1. Because I know you do e to the natural log of x minus 4 equals e cubed. From there, I think what you have to do is this. Hold on. So e to the natural log of x minus 4 equals e cubed. So it's just weird because, let me see, 3 natural log of e. And then oh, I don't remember how to do this one. This one's really weird. If somebody knows how to do it, please let me know, because I really don't remember. It's been a while since I've done these. yeah, I mean, I seriously do not remember how to do these. So if anybody, if you know how to do this, please let me know, because, like I said, it's been a while, and, natural log of x minus 4 equals 3. Because I know you do this. You definitely do this. So it would be natural log of x minus 4 times e equals e cubed. I think it goes like this. So this goes in the front, right? Natural log of x minus 4 times e, and then you do natural log of e of the natural log of x minus 4. I mean, of x minus 4, right? And then is equal to e cubed. So then you just do 1 times x minus 4 equals e cubed, and then you do x minus 4 equals e cubed. You add 4 to both sides, and you get x equals e cubed plus 4. I think that's how you do it. I mean, I mean, like, I think that's the process. I know that the what is it called? I know that the answer is e cubed plus 4. Like, I know that's what the answer is, but I don't remember if that's the way that, you know, that they did it. Let me just check. So a natural log of x minus 4 equals 3. Where y equals 3. Okay, yes, it is. It is. This is, I mean, this is how you do it. The only thing I don't understand is why. So, okay. If you have e, so if you have natural log of something, it's like if I say natural log of x equals 1, right? So then I say, okay, e to the natural log of x equals e to the first power. So then I say, hold on, e to the natural log of x equals 1 times natural log of e, which is e to the natural log of x equals 1, I think. Give me 1 second, guys. I will be right back. Okay, sorry guys, I am back. Sorry, I had to take my medication. I am back now. So, okay. This is how you do this one. I mean, I don't know how else to properly explain it. Yeah, so, I mean, I know that, so I am gonna do one more, so if I say, let me see, so let me do a logarithm equation. Let's see. Excuse me. So, let's see. Okay, so let's do this one. Log. So this one is log base 4 of 3x minus 2 equals 2. And we want to solve for x, right? So the way that you would do it is you have to grab this number and you have to put it as the base. So it's going to be 4 log base 4 of 3x minus 2. And you're going to do it is equal to 4, and you're going to put this power, this is going to be a power, so it's going to be 4 squared, like that, right? So then you cancel these out, you get 3x minus 2, because remember, anytime you have anytime you have like n to the log base n of a power, this is really just a, right? So really you're going to have 3x minus 2 is equal to 4 squared, which is 16, and you're going to go ahead and add 2 on both sides, and you get 3x equals 18, divide by 3, and you will get x equals 6. Okay. I'm trying to see what other ones there can be. This one's interesting. So this one says, this one is log base 2 of 5 plus 2x. So let me actually equals log base, or sorry, minus log base 2. So minus log base 2 of 4 minus x equals 3. And the way that you're going to do it is, so the way that you're going to do it is you're just going to go ahead and you're going to use, so basically whenever you have log base b of a minus log base b, actually hold on, when you have log base b of x minus log base b of y. This is really just log base b of x over y. Okay. I might end the stream in a little bit, guys, only because it's starting to rain and yeah. But this one, this is how you would do it, and then you would do 5 plus 2x over. So basically what this is saying is, because they have the same base, you just go ahead and you do this. Okay. They have the same base. So basically, this is basically saying... Actually, hold on. Hold on, I'm wrong. I'm wrong. It's like this. So you're gonna say... You're gonna take the log base, you're gonna do log base 2, and you're gonna do the following. Log base 2 of 5 plus 2x over 4 minus x equals, and you're gonna do equals 3. Now, here's the part where you're really gonna have to, like, you know, you're gonna have to use your properties of logarithms. So basically you're gonna say 2, because you want to get rid of the log, right? You're gonna say 2, and you're gonna do, let me just do it this way, 2 raised to the log base 2 of 5 plus 2x over 4 minus x is going to be equal to 2 cubed. And you're going to put this in the front. So you're going to say, so this cancels out, and you're going to say 5 plus 2x over 4 minus x equals 2 cubed. 2 cubed is 8, so you're going to say 5 plus 2x over 4 minus x equals 8. Like that. So then you're going to just use, you're going to multiply 4 minus x on both sides to get rid of the denominator. So, like this. And these cancel out, and then you're left with 5 plus 2x equals 8 times the quantity of 4 minus x. You're going to use distributive property. You're left with 5 plus 2x equals 32 plus 8. Or 32 minus 8x, excuse me. And then you're going to add 8 on both sides. So then this gives you 5 plus 10x equals 32. And you're going to subtract 5 on both sides. This is going to be, how much is it going to be? $27. So 10x equals 27, and then you're going to just divide by 10 on both sides. And you're going to be left with, x is approximately 2.7. And that is how you do it, okay? That's how you do this one. With that being said, guys, I think I'm gonna stop the stream here, only because it's raining, and yeah, I don't want to, yeah, I don't want there to be a risk of lights going out and everything, so, with that being said, guys, thank you so much for watching. If you have any further questions, or if you want to like, so if you want to tweet me any questions that you have about math in general, I can put my Twitter in. So let me go ahead and just type my Twitter, just so that, you know, if you guys have any questions, I can do it. And since I don't have a community post thingy, like I can't post community yet because I have to have like 1,000 subscribers to do that. So I can't do that right now. So if you have any questions, my Twitter is the following. So let me put my Twitter in the description, or not in the description, sorry, in the let me put my Twitter right here. So let me see. It's gonna be so this is my Twitter, if anybody's wondering. This is my Twitter, okay? So if you have any questions, or if you are just, you know, curious about anything with any math, I can, you can tweet me, or if you have any questions, like you're stuck on a problem, or if you are, oh, my bad. I didn't show it, hold on. It's this right here, so it's this. So if you have any questions about, you know, about anything with math, if you have any questions with math or anything like that, then please let me know. And I will do my best to answer as best as I can. So yeah. With that being said, guys, thank you so much for watching, and I will see you guys next time. Bye, guys.